It's another time on easy math and circuit. In this video, we'll be looking at how to find the derivative of sine x using the first principle. And by first principle, we'll be using the definition of derivative formula. There are two things that need to be noted beforehand. The first thing is the limit of sine theta over theta as theta approaches 0. So the limit of sine theta over theta as theta approaches 0 is equal to 1. And the second thing to be noted is this trig identity of sine A minus sine B to be equal to 2 cos A plus B over 2 sine A minus B over 2. So these two things must be noted in order to use your first principle to find the derivative of sine x. Now, according to the definition of derivative formula, we have f prime of x to be equal to the limit as h approaches 0 of f of x plus h minus f of x all over h. If you want to know how this comes to be, you might want to see one of my video titled The Slope of a Function, the Basics of Differentiation. Now, given that our y is equal to sine x, which is what we want to find its derivative, to factor this into this formula, our f of x is equal to sine x, and our f of x plus h is going to be sine x plus h. Wherever you see x, you just replace it with x plus h. Now let us factor this back into this formula. Therefore, our f prime of x, which is standing for the derivative, is equal to limit as h approaches 0. F of x plus h is the same as sine x plus h, then minus f of x is the same as sine x all over h. At this point, we have to refer back to this our trig identity. And if you compare this sine a minus b with sine x plus h minus sine x, we see that our sine a is equivalent to sine x plus h and sine b is equivalent to sine x. Therefore, our a is equal to x plus h and b is equal to x. In that wise, sine x plus h minus sine x is going to be equal to 2 cos a plus b is going to give us x plus h plus x, then everything over 2 sine a minus b is going to give us x plus h minus x, then everything over 2, then all over h. Let's clean this up. Therefore, our f prime of x is going to be the limit as h approaches 0. We have 2 cos x plus h plus s is going to give us 2x plus h all over 2. Then sine x plus h minus x is going to give us h over 2 all over h. Now, let us divide both the numerator and the denominator by 2. And if we divide it by 2, the 2 is going to cancel these 2. Therefore, we'll be left with cos 2x plus h over 2 sine h over 2. Then the denominator is going to be h over 2. If we bring this out here, we have 2x plus h over 2. By separation, we are going to have 2x over 2 plus h over 2. So this will cancel this and we'll be left with x plus h over 2. So we can safely replace this with this. Therefore, we have our f prime of x to be equal to limit as h approaches 0. Then we have cos, this is going to be x plus h over 2 sine h over 2 all over h over 2. This can safely be written as limit as h approaches 0. We have cos x plus h over 2, then sine h over 2 divided by h over 2. If you can remember at the beginning of this video, I said one of the things to note is the limit of sine theta over theta as theta approach 0 is equal to 1. So if you compare this with this, we can see that sine theta over theta is the same as sine h over 2 over h over 2. So if this is equal to 1 as theta approach 0, that means sine h over 2 divided by h over 2 as h approach 0 is also going to be 1. In that case, our f prime of x is going to be, as h is approach 0, that means this limit will be removed. Then we have x plus h over 2, as h is approach 0, this is going to become 0. Sine h over 2 divided by h over 2 as h is approach 0 is therefore going to be 1. So that means our f prime of x is going to be cos x multiplied by 1, which is the same as cos x. If y is equal to sine x, that means the derivative of y with respect to x is going to be cos x. In my next video, I'll be showing you how to find the derivative of sine x using the step-by-step analytical method. Don't forget to subscribe to this channel. God bless you.